Yeah. So, as we discussed yesterday, up to three, and the fourth topic is simply the transmission control protocol. So, it is a connection oriented and it is having some facilities and it is having some services in a transport layer. So, there are some different services I want to mention here. The first service is simply stream data transfer. Okay, the first one is stream data transfer. So what is the stream data transfer here? So the TCP protocol transfer the data in the form of contiguous stream of bytes. What is the contiguous in the sense? So side by side, so adjacent manner. There is nothing but they are not going to disturb. The order is not going to disturb. So for suppose if you want to follow a simple queue, so they must and should be in the order. So order of bytes, not changed. The entire transmission also they are not changed. That one we called contiguous stream of bytes. TCP group the bytes in the form of TCP segments. So each one is divided into TCP segment. Okay, so each one is converted into TCP segment. So with respect to the TCP segment only, it can transfer the data. So next one here the transmission of the IP address depends upon IP address. So from source to destination, that is generally you call it is a TX to RX. So you call it is a source and destination always. Okay, IP address starting from source and the source address and destination address depends upon that both the things only it can transfer the entire data. So, and the packets are the segments, they are not going to be disturbed anymore. So, that is nothing but stream data transfer. Okay. So, TCP itself segments the data and forward to the IP. So, according to that IP, it will forward. Okay. So, if there is a big message, or so just this one only called packet. So, that packets are divided into small segments, small segments with some numbers. So that one I called ID. So identification numbers are there for each one. So according to that identification numbers, so they are going to transmit from source to destination. That is nothing but stream data transfer. Okay. The second part is nothing but reliability. It is more reliable. Okay. So reliability of the system is very high. So high reliable. So this the sequence number of each byte transmitted and expects a positive acknowledgement for the receiving TCP. So always we are sending the data, send and expect for ACK. So ACK means compulsory it is a positive one. So data is transmitted properly or data is received properly like that. Some acknowledgement is coming from the receiver. So always the transmitter sends the information and waits for some acknowledgement. Okay. So if acknowledgement is not received within a time limit or time interval or a span of time, so then the data is transmitted. So that's why it is very reliable. So if no acknowledgement, if no ACK in time, okay, in time. So if there is no ACK acknowledgement is not came within the time limit, so within the time interval or something what you call the time span, so must and should retransmit. Retransmission is possible. Okay, that's why the reliability is increased. So then the receiving TCP uses a sequence number to reassemble the segments. It only arrives out of the order or eliminate the duplicate segments. So, for suppose sometimes some segments are coming in a different way. That means if I send in the order of 1, 2, 3, 4. So these are my sequence numbers. But sometimes maybe there is a chance of getting 1, 3, 2, 2, 4, 3. So like this I received at the receiver. So at that instant, the receiver role is here simply it will reassess the data and only it must and should construct by means of sequence numbers only. So it will eliminate the duplicates also. That's why this system is very very reliable. So the reliability of the TCP IP is very high as compared to UDP. So next, third one, the third thing is nothing but flow control. What is the flow control? So the flow control simply always when receiving a TCP acknowledgement back to the sender. So indicating the number of bytes it can be received without overflowing or without any data loss, without any error. So the internal buffers will take care about the flow control. That is nothing but slow one is there, so fast one is there, maybe slow receiver and a fast transmitter. So in that case, so the buffer is will take the entire control. So that's why the flow controlling is also one of the major technique. So the number of bytes is sent in acknowledgement, so in the form of an acknowledgement. So the highest sequence number it can be received without any problem. So that always, so we are thinking about the acknowledgement is coming or not. For each one I don't get the acknowledgement like that. So depends upon the buffer size, depends upon the sequence numbers. The flow control is very very highly organized in a TCP IP. So the mechanism also referred as window mechanism. So this one only the flow control mechanism in the TCP is called window mechanism. So I hope you are writing a short note like that thing. Maybe in notes these all are not covered. Yes. So what I am discussing now. So this technique only you call window windowing or window control. So that was simply you can compare with the sliding window protocol. So always you are expecting an acknowledgement. So that acknowledgement and everything are how they are possible means by means of internal buffers. Must and should there is a buffer inside and the queuing capacity is there for the uh, without losing or without any congestion. The data must and should be transferred from one place to another place. Next, you as you know, so yesterday we talking about transport layer. So what are the services means? So multiplexing and demultiplexing. Here, so it is responsible for multiplexing also. Okay, so multiplexing technique. So you know very well multiplexing. It is a process of accepting the data from different applications or different process or different or multi number of systems. So for from multi computers. So and these are received data is forwarded and corrupt the application. So the entire process is nothing but simply combine all the signals together and make into a one carrier signal. And this process is nothing but at the end we are going to retrieve the data back by using demultiplexing. So this transmission of packets, so through this technique is called multiplexing and demultiplexing. So the technique is simply many to one. Okay, many to one. So is nothing but mux. So always you know this thing. So one to, so many is nothing but demux. So demultiplexing. So this is digital electronics and everywhere you studied very well. So DC also you studied this thing. So always the carrier is divided into more number of channels, so that FDM, TDM and the CDM. So multiplexing is required always if you want to send certain information from one place to another place. So because they have different frequencies, they have different timing, and they have different amplitude. There, so depends upon their the characteristics only we are going to divide them into different channels. So each channel consisting of, so the multi-rate signaling. So such techniques we call multiplexing and demultiplexing, the process. The next, logical connections. It can maintain certain logical connections. The fifth point is logical connections. So the TCP IP responsible for logical connections also. So the combination of sockets. So do you know Java? So when you are talking about Java, so must and should Java RMI is depends upon the socket. So the socket programming is very important. Yes. So because port number is there for each socket. So the sequence numbers and window sizes are also very important. So how many at a time you can pass and what is the throughput for that window. So like that the window size is very important. So these type of entire information you called logical connection. So each connection is identified by the pair of sockets used by the sending and receiving process. So each process can create certain socket. So the socket is nothing but a logical entity. This logical entity consisting of three scenario. One is nothing but what, the window size. So window size. So the second one, it must and should uh, require certain identification number. Okay, so identification number as well as sequence number. Okay, so that is nothing but sequence number and compulsory a pair of process. So these two processes are where they are. These are compulsory. One is at a transmission side. One is at a receiver side. So these type of entire information maintained by this socket by means of a logical connection. That maintenance is what you call logical connection of the TCP model. So next, so this full duplex mode. So already you know that full duplex mode means what. So the TCP/IP always provides the communication in a full duplex mode. So full duplex mode. So in this full duplex mode, we are always establishing the connection between the two TCPs and data exchanging or data transmission. So from sender to receiver or receiver to sender. So both are used as a transducers. At that moment, both the things are transceiver. Generally, it is called transceiver. So they can use modem. Modem is nothing but what? So the modem consisting multiplexing and demultiplexing both the operations. So they can modify the data according to the numbers and everything. So data exchanged between the both the directions from sender to receiver, receiver to sender also. The connection is terminated. So this is a very important format. So whenever full duplex mode means what? So at a same instant, the both sender and receiver can transmit the data into the medium. Okay, so they can receive, they can send the data at a time. So such type of scenario we called it is full duplex. So simplex means only one direction data is moving. That is called simplex. But here it supports for a full duplex thing. So how it is full duplex thing is supported? Simple. The following steps occurred. So when the full duplexing mode is occurred. So that means first of all we need to so setup. So that one is connection page or setup page. So after that setup, you must and should data transmission. Data must and should be transmit. So and receive. So must and should both are possible in any time. So at any node. So from sender also it can converted as a receiver. So receiver also it can converted as a sender. So after that the connection must and should be terminate. This one only you call it tear down phase or termination phase. Okay, the termination or terminated. Okay, the must and should be connection must and should be need to set up. So data must and should we need to transfer in a full duplex mode. So and after that the setup is going to be terminate. So these are the total TCP segment can do these all things related together. So one is nothing but simply um, stream data transfer and reliability of the system. Reliability means how strongly it is recommended and how quality of service it is giving, and how long it is trusted. So what are the facilities to that reliability? Next, to stream data transfer is nothing but the packets are divided into small maintainable segments, each one consisting a sequence number. With respect to that numbers only, reconstruction is possible. So next, flow control. The flow control is occurred by means of the third category is flow control. That is by means of the overflowing and everything are controlled by buffers as well as queue sizes as well as sequence numbers. The reconstruction also possible at the receiver side. So this entire mechanism what we call window mechanism. So next fourth point is multiplexing. So multiplexing is occurred across the any type of data communication. To maintain or to use entire bandwidth, you must and should use multiplexing operation. So many to one is always multiplexing. So one to many is nothing but demultiplexing. At sender side you are going to multiplex the signals and make into one signal, and at receiver side we are going to demultiplex the signals, and with respect to the destination we are going to distribute the data. So next to logical connections. What are the different logical connections we means? So the window maintenance is done by means of socket. So always we are thinking about the socket. Socket is an entity which is having certain identification number, and pair of sockets must and should be generated by sender processor and receiver process, and the window size. So you must and should require the window size, how much size it is. So these are main things in a logical connection. So last topic is full duplex. What is the full duplex operation means? So at any instant of the transmission, data reception and transmission both are possible. Such type of communication is called full duplex mode. So in this full duplex mode, the must and should we need to support for establish the connection between the two TCPs and data exchange in both the directions, and as well as connection must and should be termination. Connection termination is also required. So this is about the first part. So in this, so now we are going to discuss about TCP segment format. So what is the TCP segment format? So this one only you call it is a TCP header format or TCP segment format. So header we will later, but first of all we will see the segment. So what are the main things involved in a TCP segment? So first, source port address. Source port address. So what is the source port address? Or you are always thinking about the source address, destination address, a sequence number, acknowledgement number, so destination port address. So these port numbers are very very important because it is a connection oriented protocol. Must and should require some ports. So the header is different. The header consisting of these things. So data is nothing but it is a payload. So around 1540 bytes it can transmit at any instant. So source port address is 16 bits and destination port address is 16 bits. And sequence number. So the sequence number, so which is represented by 32 bits, and acknowledgement number, so 32 bit, and HLEN, and reserved 6 bits for future scope. So URG, ACK, PSH, PST, and SYN, FIN. So these are the different flags for entire process. And window size. So window size 16 bits. So how much window size that must and should you need to mention. So in this window size, and next we need to mention checksum. So checksum is for error detection purpose. So urgent pointer. So for suppose some bits are very urgent, so at that instant in must and should this pointer must and should be point to 00027. So urgent pointer is also required, and options and padding. So some options, so and padding. So these are required for fulfill the packet. So we'll see one by one. So these fields. So what are the fields and what are the requirements of each field? So the source port address always it is a 16 bit. So it is defined. the address of the application program at the sender side, not at receiver side, sir. So source in the sense sender. So sender computer or source computer. So it is a 16-bit field. Next, destination port address. It is used to define the address of application. So application programs are. It is not a system address. You must and should remember the both are different. IP address is different. This one is different. Port address is different. So this port address is related to the destination port address. So the application program in a destination computer, it is also 16-bit. So next to sequence number. So all must and should require certain sequence numbers, depends upon the packet number of packets. So the stream of data divide into two or more TCP segments. Yes, we know already. So several segments it is converted into TCP data. So the 32-bit sequence number or the number of fields represent the position of the data in a original data stream. So in what position it is there, the sequence where it is going to start, after which data I want to start in the next one. So like that, the sequence number is used for reconstruction of the data and validation of the data at the receiver side. So for that purpose, you can use sequence number. It is a range of 32. Next, to acknowledgement number. Yes, this is must and should do for reliability purpose. So once the data is sent, if it is received properly, must and should need to get the acknowledgement. So here, from this onwards, you don't know these all fields. Yes, if acknowledgement field is set to 1, then the sequence number that the receiver expecting to receive. So acknowledgement number means simply if acknowledgement is equal to 1, so the receiver is going to expecting the bit or the port it is coming from the sender. So like that it is expecting. If it is 0, already received. So like that acknowledgement is sending from one place to another place. Next, header length, HLEN. So you write sir these things, header length. So previous one all the things very easy to understand. So these things are very important. HLEN. So what is the header length? So the header length is 4 bytes. Okay. So it specifies the TCP header in 32-bit words. So the header type, it you can tell. So the minimum size of the header is 5 words. 5 words mean in the sense what? 80. Yes. So then the maximum size of the header is 15 words. Sometimes it is 15 words also. So therefore the maximum size of the TCP header is 60 bytes. Okay. So 60 bytes you can use, and the minimum size of the TCP header is 20 bytes. So whether it is 60 or 20 like that. So if you want to mention the length of the header by using these 4 bits. Okay. So at a time, total 4 bits are going to mention. So whether it is 16, what is the size? So whether it is 15, so up to 15 you mention by using 4 ones. 4 bits can represent 1111 means 15. So total 15 words are there in that. So like that. So if it is 00, no 00101. So that means what? 5 words are there in the header length. So like that you can mention the size of the header. Okay, the length of the header. So it can mention by this header length or HLEN field, that 4 bits. So next, reserved means, so these fields are reserved for future scope and future development. If you want to become a scientist, if you are a scientist motto, so then you must and should go and develop that 6 bits. So that is future scope purpose. Next, control bits. So here these all are remaining all are the control bits. So we want to control. So first one is URG. So the URG is nothing but urgent. The segment it is urgent. URG field indicates that the data is in a segment is very urgent. So that bit indicates very urgent, that one. So next, so total 16 bits are from here to here 16 bits. So 4 plus 6, 10 completed already. So remaining 6 bits now we need to talk. So if this one is 1, automatically it indicates data bit is very urgent. ACK is 0, it must and should be received by the receiver. Next to PSH. So ACK, you know, the acknowledgement. So then it validates the acknowledgement number. Simply PSH. So this is the information regarding the throughput. So uh, higher throughput or lower throughput. Okay, so it is related to throughput value. So the data must and should be at a higher throughput or lower throughput. If it is 1, the data is at a higher throughput. If it is 0, the data is at a lower throughput. Next, RST. So RST is the reset. So once again you need to retransmit the entire thing. So you must and should the reset the connection and reset the refresh the connection at a time. So that is nothing but as like a reset button in our microcontroller simply. So it can reset the entire network. So next to SYN. So this field is for synchronization purpose. We can use the sequence numbers in three types of segments. So connection request, connection confirmation with acknowledgement, and connection confirmation of the acknowledgement. In that three cases, in synchronization of the bits, bit purpose, synchronization is occurred means 1, synchronization not occurred means 0. So like that. So this will indicate the synchronization of the thing. Next to FIN. So this is a very important thing. So the finished sending data. So that is fin is nothing but finished of or finishing of the information. Okay, finishing of information using received by the TCP model that sender has finished sending data already completed. That is the final bit, final information or finished information. So that indicates yes, from sender side, data transmission is completed. So that is defined by the FIN. Then last one is window size. Okay, window size. The window 16-bit field. So it defines the size of the window. So whether it is how many bits or how many time frames like that. The window size is mentioned by the this 16-bit window size. Next, we know very well checksum. So use it to error detection purpose and urgent urgent pointer. So if this field set to 1, so because already URG flag is set to 1, then the 16-bit field that offset from the sequence number identifying that the last urgent data byte. So that means what? So maybe one packet is already sent. So in that one, only one of the part or one of the sequence number is missed. At that instant, if you are sending that sequence number by 16-bit data, as well as this urgent bit is going to be set. So must and should be urgent bit as an indicator, that is control bit, and you need to send the part of the data or part of the data bit identification number. So automatically the receiver recognizes that this is very urgent data I can use in the previous segment. Okay, like that. Next, options and padding. So it defines the optional fields. So maximum in maximum protocols, these type of fields are there. So and maximum padding you can use because whenever you are passing a 1540 bytes into some packet, so maybe 1540 bytes are not there. So at that instant, you must and should be add some extra zeros at the right hand side of the data. So such type of left hand side of the data. So such type of thing what you call options and some padding. So options in the sense you can put some error messages and everything. So they are called options. So this is about the TCP header. Okay, TCP header format. So this is the explanation. So what I did right now. So next to same, you have user datagram protocol. So UDP. I hope you are clear with this thing. So first you need to learn this diagram. So with respect to these some specifications, so you need to learn this diagram and each field. So you can easily explain that thing. Same way, today I am going to conclude with UDP. So UDP is a simple protocol, and so without a sequence transport functionality. So it doesn't require any port numbers or something. So UDP is a connectionless because it doesn't require any setup or it doesn't require any tear down phases. Simply it can send the information or transfer the data from one place to another place. So in that category, that UDP is the simplest protocol. So end-to-end transport level protocol adds the transport level address checksum for error control, and length of the information and data from the upper layers. So these are the some specialities with this thing. And the fifth point with respect to datagram protocol is the packet produced by the UDP protocol is known as datagram. Here we call it as a datagram from UDP protocol. So now, so this is the header packet. So what you have, the packet size and packet everything. So the header format is 8 bytes total. So these 8 bytes is divided into each one is 16. So the data range is so maximum 1540 bytes. Okay, 1540 bytes up to you can transfer. So here source port number 16 bits, destination port number 16 bits, total length 16 bits, and checksum 16 bits. So you can easily explain these bits. So what is the port number means here? So that is the address of the application process that delivered a message. So where I want to deliver a message for that software or for that application, it must and should require a port number that is a length of 16 bits. Next, to destination port address. So it identifies the address of the application process that will receive the message, and the destination of the port in a 16-bit address. So both are 16-bit address, source as well as destination. So next, total length. So this is identifies the total length of the user datagram byte. So how many bytes are there in the total? So in that, the what is the payload? Payload generally you call it as a payload also. So the data, entire data, how many bytes are valid in that? So that is mentioned by total length. So checksum. Checksum is which is for error detection purpose. We are going to use as a 16-bit data. So these are the main things. So you must and should observe some things are some disadvantages are there here. So UDP provides basic functionality, yes. So for the end-to-end delivery of the transmission, so it provides only basic things. So but TCP very very reliable. So that's why it is somewhat drawback, and it does not provide any sequencing or reordering of functionality or reordering of the data. So reporting an error, error reporting, nothing is there in this. There is no acknowledgement also at least. So that's why this is somewhat unreliable, untrusted, so unsecured. Okay, so these are the some drawbacks. Next, UDP can discover if the error has occurred, but do not specify which packet has been lost, or which packet only I need to transfer, which packet only I need to resend. So such type of information is not given by UDP. So that's why it is somewhat unreliable or untrusted, and throughput is high, but the data rates are high with a lot of error. Okay, so the sequencing numbers are partial, so it doesn't show any sequential number, or it doesn't show any type of representation. Okay, so that's why these are the some drawbacks we have with the UDP. So these are the some differences between TCP IP and the TCP and UDP. So transmission control protocol TCP, user datagram protocol UDP. So, as usual, TCP is a must and should question, sir. So, today, what is the class in this must and should question? In SI, compulsory it is there in SI. So, either UDP or TCP, or the differences between UDP and TCP. So, in between the three, A or B or C, so in that must and should be, there is a question. So, in an SI, in fourth unit. Okay. So such type of important thing. So here this one you must and should learn. So it is a connection datagram oriented protocol. It is a connection oriented, and it is a connectionless also you can write. So it is reliable, as it guarantees delivery of the data to the destination router. So the delivery of the, so the delivery of the destination cannot be guaranteed in the UDP. So here the TCP provides extensive error checking mechanism. It is because it provides flow control and acknowledgement of the data. So it can provide the flow control and acknowledgement and everything. So UDP has only one basic error checking mechanism using checksums. So by using only checksums only it can. So it doesn't provide any error mechanism and anything. So it is a drawback. Next, the sequencing of the data is a feature in transmission control protocol. So it means packets arrive in order at the receiver. So there is no guarantee. So there is no sequence of the data in UDP. If ordering is required, it has to be a managed by the application layer. So we don't the transmission control or the transfer control protocols or transmission layer or transport layer is not responsible for that in UDP. So only in UDP, the thing is it must transfer. Next, TCP is comparatively slower than UDP. So somewhat slow, okay, because it is having a lot of responsibilities. That's why it is somewhat slow as compared to UDP. So UDP automatically it is simpler and more efficient. It is faster. Okay. So next, retransmission of the last stop packets is possible in TCP. So there is no retransmission or of last packet in the UDP. So TCP has 20 to 80 bytes variable length header. So it is a 8-bit fixed length header. So there is no change. TCP is heavyweight. So it is somewhat the maintenance is also very complex. The TCP is because it is very weight. So UDP is a very light protocol. Next, TCP doesn't support broadcasting. In broadcasting of the signals and everywhere, it doesn't support. So UDP supports the broadcasting. So that is the one of the major advantage in UDP and TCP. So this is these three topics only we covered today. So one is nothing but TCP, Transmission Control Protocol. The second one is UDP, User Datagram Protocol, and the differences between them. So that is the agenda of today's class. So that's it. So after giving the your attendance, you just go. So just please respond the roll calls. So message you type sir simply. So according to my call, you type in the message box. That is easy to note all the things. Yeah, 96 to 100. Nobody there from 96 to 100. Attendance. Type in a message box. Hello. Yes, 98%. Yes. So 100 to 110. 100 to 110. You just type sir. So you type in a message box. So that is easy to take me. Okay. No need to tell the attendance. So directly you type in a message box. So then I can easily. Total 40 members present today. Okay. So next 110 to 120. 110 to 120. Hmm. Okay. 113 వచ్చిందా? Okay. So 115. 119. 118. 102. Next 121 to 130. Yes, 121 to 130 completed. So then 130, 140 up to 140. 131 present, 132 present, 133 also. No, 133 present, 134 present. So 133, 134 to 137, 138. 138. Okay, done. So you can leave, sir. All of you leave. So next lateral entry. Lateral entry up to 10. 301, 303, and 308. So next lateral entry up to 20. 307 also present. Okay. So up to 20. So 312 and 100 also present. 100 is here. Okay. So 316 present. 318 present. 320 present. Okay. Okay, thank you. So tomorrow we are going to conclude. So fourth unit. So moreover, we have only two topics. One is ALL layer. So that ALL layer we'll see. So tomorrow. Okay. Thank you for participation. So ATM adaptation layers ALL protocol. AAL actually. ATM adaptation layer protocol. So that is easiest topic. So tomorrow I will conclude this one and as well as ATM. Both two topics together I will conclude up to 4 units. It is completed for tomorrow. So next we will start fifth unit. Thank you. You can leave the meeting. So I'm not closing the meeting because I have another class right now. So that's why same link I'm using for that thing.